So last time we were looking at red blood cells and where they're made and what hormones help those the red marrow to make red blood cells, hematopoiesis, and how those red blood cells are broken down by the liver and how we recycle the amino acids and recycle the iron, and the biliverdin is a lot of it's converted to bilirubin and stored as bile and released into the blood or into the you don't want that in your blood, released into your urine or in your intestines. Now we move to the white blood cells or leukocytes. Leuko means white, cyte is cells. So these are the white cells, the white blood cells specifically, and they are fighting for you. This is what keeps you alive against this dirty war that you are in every day, fighting foreign bacteria, virus, fungi, and even some protists. So, and worms. Oh my gosh. So leukocytes have a limited lifespan, and so they should be replaced, similar to our red blood cells. And they're also produced in red bone marrow and under hormonal control. Interleukins and other factors help stimulate white blood cells to be made. There are 5 types of white blood cells, and they categorize them based on what they look like when you stain them and look at them under a microscope. So we have the granulocytes, which, if you look in the cytoplasm, have grains, little like grains of sand inside. They have a very short lifespan, and they are all the fills. So underline granulocytes and think of, you could feel the grains in the cytoplasm. That's how I remember anything that ends with feels are the granulocytes. They have the granules inside the cytoplasm. So we're talking about neutrophils, the eosinophils, and the basophils. The agranulocytes, you're not going to feel any granules. You can't see them. So no feels belong here. These are the other 2 types of white blood cells. Agranulocytes, lymphocytes, and monocytes. Remember, never let monkeys eat bananas can tell you the names of the white blood cells in order of greatest amount to least amount. And then all the fills are the granulocytes, and everybody else is agranulocytes. So white blood cells can do some pretty crazy, awesome things. One is diapedesis. Dia means through, ped as in foot, where you put your pedal, and esis is a process or condition. So they can walk through things, and it's weird because they're able to move through your tissues, and they're constantly leaving capillaries and going out of the blood vessels and going into your connective tissues and into your different organs, looking for foreign objects to help you fight that war that you're in. We're going to see that a lot of them are found in lymph nodes, and they just move all over. It's kind of freaky to think about. They do have proteins that direct these white blood cells to injury sites and kind of help them stick. And because those help them stick, they call those cellular adhesion molecules. Some white blood cells are able to do phagocytosis. Now, phag or phage means to eat, and cyte means cell, and osis is a condition of. So this is a cell that has a condition where it's able to eat, and it is a single cell eating other things. So it actually surrounds whatever it's going to digest or take in. It engulfs it. It forms a little food vacuole and uses its lysosome with enzymes inside to destroy it. And these are going to be your neutrophils and monocytes that are your most mobile and active phagocytes. They're neutrophils and monophils. So I told you I'd never write, but if you wrote, I can't even write on here. I'm on my Mac, so gosh. But if you wrote never in here and then here, L, let, M, monkeys below the L. Never let monkeys eat, eosinophils, bananas. You have this like question mark. Never let monkeys eat bananas. And neutrophils, Leukocytes and monocytes, those are your agranulocytes on the right, and then your granulocytes are on the left. And then if you draw a line right here from never and monkeys, that's going to help you remember the neutrophils, and the monocytes are the phagocytes. Maybe I'll draw this for you, but that's what my students and I do inside the classroom on the whiteboard, and that really helps, or they told me that really helped them. And a lot of them got those right on the test. So the neutrophils and the monocytes are your phagocytes. Neutrophils being granulocyte, we know that because it ends in "phil," and monocyte, agranulocyte. There's a process that is called inflammatory response, and we'll talk about this a lot. But when you become injured, your injured cells release histamine. And what that does is attracts white blood cells to the area. So the inflammatory response, it says this is a reaction that restricts the spread of infection, and basophils have a big to-do with this. And they inflammatory response secretes heparin and histamine. I already mentioned that. And it involves this swelling. So when you talk about an inflamed area where you like, people will see it's inflamed and they go, oh, you've got an infection, and you're seeing histamine probably, and you're thinking, wait a minute, for my allergies, I take an antihistamine. Well, allergies are a overreaction to pollen. So your body says, oh my gosh, let's say it's pollen. Pollen, it's deadly, let's fight. And you have this inflammatory response, and you're trying to stop the pollen from going all over the body. And look what happens. You increase the capillary permeability. Your capillaries become real leaky. And so that's why you have all this snot and mess going on in your sinuses, because your body's reacting. It's trying to fight this fight against pollen. Now, is pollen really dangerous to us? No, it's not. But your allergies are issues where you kind of, I call them the drama queen, the cells just overreact. Now, positive chemotaxis, taxis, you've seen the word taxi, that helps you move. So this has to do with movement. And chemo, it's movement in response to a chemical. And it's positive. So this is where something is going to move towards a chemical. Negative chemotaxis would movement away from a chemical. And then there's like phototaxis, movement towards light. You see plants do that, right? And then negative phototaxis would be movement away from light, like roots would do. So positive chemotaxis is this attraction of white blood cells to the infection site because of these chemicals released, that histamine released by the damaged cells. It's going to kind of attract these white blood cells to that area of infection. That makes so much sense, right? We just broke through the skin. Bacteria and fungus can get inside. We want the white blood cells in that area. We don't want them, chilling in the lymph node right now. We need them all headed to this area to fight anything that might have broken through that cut. So this is like a cartoon picture of diapedesis showing how this white blood cell is kind of amoeboid, and it can squeeze its body and make these, they would call this like a pseudopod, a fake foot. And so diapedesis, it's walking through this capillary, which is probably leaky and going into the tissue. And here's one that's already there to look for any bacteria or fungus or things that shouldn't be there. And then they'll do phagocytosis. So this is that inflammatory response story I was mentioning earlier. So dang, this splinter's scary, right? I don't want this splinter. So it punctures your epidermis. It's down into your dermis. Oh my gosh, the capillaries are there. You're bleeding. It's gross. Bacteria was on that splinter. And oh my gosh, they're dividing and you've got infection, y'all. And so what's going to happen, these injured cells you can see that you broke a capillary. So they're going to release histamine, and that's going to cause all these blood vessels to become leaky. And what will happen? Well, diapedesis, these neutrophils are out. Remember, neutrophils are phagocytes, so they can destroy that bacteria, and they're going to gobble that bacteria up so that it can't, multiply and have a serious infection. New, uh, again, it's saying they're moving through the walls and they're headed, the neutrophils are headed towards this site because of histamine and positive chemotaxis. And this is the inflammatory response. This will look swollen and red and be painful and hot to the touch. Why is it red? Because there's blood coming to this area. How is blood coming to this area? Because we've increased, increased the blood vessels. We've done vasodilation. So more blood's coming to the area, which is, remember, blood is mainly made of water and water holds heat. So that's why it's hot and it's swollen because you got more stuff coming to this area and it hurts because it's swollen. All right, let's get into the nitty gritty. Let's talk about these white blood cells. You're going to need to know, what these white blood cells are used for and be able to identify them under a microscope. So neutrophils and eosinophils, they end in phils, so we know they're granulocytes. Now, neutrophils have small purple granules in an acid-base stain. If you've taken microbiology, you know about acid-base stains and I just lost all my knowledge on microbiology. Fast stain, I don't even know. I'm not going to pretend to know. And this isn't microbiology, this is anatomy. So let's move on. When you stain these guys, they're going to have this light purple granules, and you're going to see this funky nucleus. It's lobed. It's not a perfect circle like everybody thinks. It's got 2 to 5 sections of this nucleus. And these neutrophils are also called polymorphonuclear leukocytes. We won't ever call them that, but you might hear that in the other world that you are going to. They are usually the first to arrive on site. Well, why? Remember, this is the one we have the most of. Never let. This is the one that's you've got traveling all in your blood that you're making the most of. So sure, they're going to be there first on site, and there are strong phagocytes, and they move through diapedesis, and you see them in bacterial infections, just like we saw with that splinter. Now, eosinophil, another granulocyte, has coarse granules, not little small ones, but coarse ones, and they stain red. They're real pretty. And the nucleus is bilobed, so it's just going to have 2 little sections. And this is going to respond a little bit to allergic reactions, but here's what you want to remember. Not just allergies, but parasitic worm infections. And guys, I have some bad news. If you ever went to daycare, you probably had some wormy stuff. Kids are nasty. Now, never let monkeys eat. This is one of the smallest amounts you have. We don't usually have parasitic worm infections, and we kind of have some allergies, but not in high amounts. Now, if you're having an allergic reaction, if you do have a parasitic worm infection, these numbers would be elevated. So remember when we were talking about, like, how do you diagnose something using this information? Well, if you have a whole ton of neutrophils, more than you should have, more than 70%, that person's got a bacterial infection somewhere. And you, as a nurse and a doctor, y'all have got to find where that infection is and get the right medicine to stop it, kill that bacteria. If you have an elevated amount of eosinophils, look for worms. Or is this person having an allergic reaction to the medicine that you're giving or whatever? And so here's what I'm talking about. Tiny purple granules and this weird funky shape multi-lobe nucleus here. Now here we have coarse, big old fat red granules and a bilobed nucleus. And then these are actually little platelets. Aren't they cute? Remember platelets? All right, basophils, our last granulocyte, has large granules that stain deep blue in a basic stain. And these can kind of block the nucleus. These release histamine, and they help stimulate that inflammatory response. And they also release heparin, and that stops blood from clotting. We don't want a blood clot right here. We want blood to flow so that the white blood cells can come. This is the never let monkeys eat what? Bananas. It's the least amount that you have. And they look a lot like eosinophils in their size and their shape of their nuclei. Now, if you have a whole lot of these, it could also be due to some damage to cells. Okay. Monocytes are first agranulocyte. It's the largest. So think of megacyte, monocyte. Mono means one. It's the big one. And it has a kidney shape, spherical nuclei. It can be lobed. And these will leave the bloodstream and become macrophages. Now, they're not going to be the first to arrive on the scene and be macrophage. Remember, those are the neutrophils. But the monocytes, they show up eventually. Never let monkeys. We have a moderate amount of these, about 9%. And they can live anywhere from weeks to months. And they're going to fight any dead cells, bacteria, debris. And so here you see the basophil with the pretty purple stain, and they're you can even see them covering up the nucleus. And then here, look, no granules. This is not a fill. This is a granulocyte, and it's a big one. These are red blood cells, and a platelet for you to kind of see an example. So this one, is about twice as big. This one is 3 or 4 times as big. Monocyte. And last is our lymphocytes. Now, star these because we're going to really focus on these in units to come when we talk about white blood cells fighting specific foreign antigens or pathogens. So they're pretty small. They're only a little bit bigger than the red blood cells. So they are the smallest of the white blood cells. Now, we have a good amount of these. Never let. So neutrophils the most, lymphocytes are right next to it. They do have a large spherical nucleus, finally, a normal nucleus. And it's surrounded by the rim of the cytoplasm. Of course, it's agranulocyte because it doesn't end the word feels. And specifically, the lymphocytes are T cells and the B cells. And we know that this is going to be immunity. So T cells are going to attack usually infected cells or tumor cells, cancer cells, and B cells produce antibodies to fight whole antigens or help fight the disease and cause secondary immunity. And these can live for a long time, especially the memory cells, the memory B and memory T cells. I don't want to go into too much information about these because we have like half a unit on that. So more on that to come, but you can see huge nucleus, almost the size of a red blood cell, teeny tiny little guys, but super important. You have a ton of them. And what are they doing? They're looking for cancer in your body. Did you know that you have cancer cells in your body right now? But if you're taking care of your body, if you're, getting lots of sleep, eating the right stuff, not stressing out too much, not putting yourself in dangerous environments, not having infections all the time, you are taking care of your immune cells, and they are taking care of you by finding these cancer cells and destroying them. So let's talk about white blood cell counts. This is what we measure, how many white blood cells, and you should have anywhere from 3,500 to 10,500 white blood cells per microliter or millimeter mercury. And I think that's also a cc. But so if you have something called leukocytosis, remember osis means condition, cyte is cell, leuko, this is a condition where you have a lot of what? Leuko white blood cells. This is a high white blood cell count. You have more than 10,500 white blood cells, and this means you've got some infection or you've had some, vigorous exercise because you might be doing some damage, or you've lost a lot of body fluids and your white blood cells are working to fight this infection. Now, the opposite, leukopenia, is a low white blood cells count. And if you have too low, that could be that the white blood cells themselves are infected. And this is really how AIDS works. But other things like typhoid fever, flu, measles, mumps, chickenpox, polio, and even anemia, right? You're going to have a lower white blood cell. If you have low blood in general, like you bled out or whatever, you're going to have low white blood cell counts. So a differential white blood cell count actually lists the percentages of the types of leukocytes. So how many neutrophils you have, how many monocytes you have. And those can give you clues on what's wrong with the person that you're getting this differential white blood cell count on. So like neutrophils tells you there's bacterial infection. Helper T cells, it tells you there might be, if you don't have a lot of those, they're being destroyed by HIV. A worm infestation would be, eosinophils or whatever. So these all give clues. Like too many lymphocytes, you could have hairy cell leukemia, which I've never heard of, but I have had mono. Mononucleosis is a viral infection, and man, I thought I was going to die. But I had a lot of white blood cells trying to fight it. If you have elevated eosinophils, like I mentioned, you might have some worm infestation or having an allergic reaction. Too many monocytes, malaria, my most interesting, remember that's a disease close to my heart. Malaria and sickle cell anemia kind of go hand in hand. TB, typhoid fever. Too many neutrophils, well, we know that's going to be bacterial infection. They're phagocytic. You have a lot of them. They come to the scene right away when you have a damaged cells. And then too few helper T cells, which is a type of lymphocyte. You might have AIDS or HIV. AIDS, really, you don't say someone has AIDS until they're having those secondary infections where the helper T cells aren't able to help fight that infection. And so they could die from things that you and I can easily, take care of. Let's talk about leukemia. You've probably heard of this before. It's the cancer of white blood cells. And so you can classify this by how fast the onset is. So acute, you all of a sudden have symptoms and it's going to progress very rapidly. Or you could have chronic white blood cell cancer, leukemia. And that's where it begins more slowly, and it wasn't really, you didn't have any symptoms, so it went undetected, okay? Now, there's types of leukemia. There's lymphoid or myeloid, and we know about those. Remember, those are those stem cells that eventually make the different types of white blood cells. So lymphoid leukemia is cancer of the lymphocytes that are produced in the lymph nodes. And when I say produced in the lymph nodes, that's where these these cells kind of reside. And then myeloid leukemia is cancer of those granulocytes produced in the red bone marrow. So what are some symptoms? You have high numbers of white blood cells. You feel so tired, headache. You're constantly having nosebleeds, respiratory infection, pain in your bones, a lot of bruising. What treatments are there? Well, there's chemotherapy, right? But that's adding chemicals, and it kills more than just what it needs to sometimes. So, and it's, we've advanced in that, but there's other things that might work too. Drugs that target the specific enzymes to the cancer cell, bone marrow transplant, stem cell, like let's get those myeloid stem cells transplanted. And then even some genetic stuff that they're working on. Let's talk about our last formed elements. We did red blood cells. We've done white blood cells. Why not? Let's throw in platelets. Platelets, also called thrombocytes, are made from little fragments of the megakaryocytes. Remember, that was a stem cell in the red bone marrow. And it is produced by hemocytoblasts in response to thrombopoietin, similar to hematopoietin. That causes hematopoiesis. So here's the storyline. You have your hematocytoblast, the stem cell, creating other stem cells called megakaryocytes, and those make the thrombocytes, which break apart and form these fragments. They don't have a nucleus because they're just kind of piece, and they're really tiny. And you've got about 150 to 400,000 microliter per microliter of blood. If you have thrombocytosis, that's high platelet counts. Too high, thrombocytopenia, too low. And what do they do? What are these platelets for? Well, as you probably figured, they help you stop bleeding. So that's called hemostasis, keep the blood in. And so when you break one of those blood vessels, they're going to stop the bleeding out of that, and they stick to those broken surfaces. And what do? They release serotonin, and that causes smooth muscles in those broken blood vessels to contract so that we can stop the bleeding process. So here are all the cellular components of blood. We got our red blood cells, a description of what they look like, how many you should have, and what their main job is to do. Then we looked at white blood cells, the leukocytes, granulocytes, those phils, neutrophil, eosinophil, and basophil, and kind of what their nucleus looks like and the granules inside so that you can help identify those under a microscope, about how many you should have, and then their functions. The agranulocytes, you can't see any granules present, so you're not going to feel them. These are your monocytes and your lymphocytes, how they look, how many you have, and their job in protecting your body. And then your platelets, helps control blood loss from broken blood vessels. All right, that is our part 2 of our lesson, our lecture. And in our last series, part 3, will be on plasma and the rest of the chapter.